let's briefly look at what are the expectations and what kind of issues which may arise when we work with recurrent neural networks versus feed-forward neural networks. In feed-forward networks, as we know, information always flows from input to the output layer. Whereas in case of recurrent neural networks, we usually are allowed arbitrary topologies. Please note this, arbitrary topologies means also multiple direction of flows. Then basically the hidden layer is always in one direction in case of feed-forward networks. Time has no role. So you run the activation from input to output now, or in after 2 minutes, after 3 cycles, after 4 cycles, doesn't matter. And one big problem in memory or lack of memory in feed forward is it cannot handle scenarios which we discussed, where there is a need for predicting a future part of the data based on a past data you've seen. So in terms of sequential modeling, feed-forward networks are not possible to capture the information because there's only one direction of information flow. That is what is handled by recurrent networks, which have arbitrary topologies. Systems can have internal states. There can be delays associated with a specific weight. Then we should also understand that cycles are possible here. But because of this complexity of the topology and cycles, etc., it is also important to understand that training of recurrent neural networks is more difficult as compared to a feed-forward network like multilayer perceptron or a CNN. And also because of the cycles, it is possible that there is unpredicted behavior like oscillation, chaos. As you all know, wherever there is control systems with feedback, any kind of natural phenomena which involves feedback loop, it's more complex to predict the phenomena because of the nonlinear nature of the whole thing.